Okay, so I'm going to move on to topic 6 with this one, and there's actually been a lot of cancelled questions here, so this one should not take as long. So I'll get through these questions quickly. Let's see. Kirchhoff's junction rule is an example of, so junction, this is about current flowing into a junction. Here's a junction here, look at that. We have a current flowing in, current coming out, blah, blah, blah. This is a conservation of what? This is a conservation of charge. Why? Because electrons are charges. Current is a flow of charges. It's a flow of charge. That's what current is. So, conservation of charge. The charge coming in is equal to the charge coming out. The loop rule is talking about voltage. If you remember, voltage from term 1 is the energy per coulomb, energy per charge, the work done per charge. So voltage is to do with potential energy. Conservation of energy, the energy that I gain in a circuit will be the energy lost in the same circuit. So that's the idea of the junction for current, which is charge, for loop, which is voltage, which is to do with energy. Over here you have currents and the segment here. What is the reading on ammeter A? So what you have is I in equals I out. Literally, this is Kirchhoff's first law. The current coming in is equal to the current coming out. That's it. I will write it, maybe I'll write it like this to make it easy. I in minus I out will equal to 0. If I do that, I can just add them, subtract them. To be honest, it's a lot easier than what I'm doing, but I'm showing you step by step. So what's coming in? We have 3 coming in, we have 2 coming in. I have 3 plus 2, and what's coming out? We have 4 coming out, 1 coming out, and 2 coming out. Minus 4, minus 2, minus 1, and also A, so I can do, I don't know, plus or minus A, so I'll just call that X, plus, I don't know if it's plus, if it's not plus, it'll come up as a negative, right? X equals to 0. You can do shift solve, and you will get your answer for this one, if you want to do it that way, and of course, by doing that, you will get the answer of 2. Now, as a logical way to do it, without having to worry about the maths behind it, think about it. What do we have coming in? 3 plus 2 is coming in. That is 5. What's coming out? Well, let's think about it. 4 plus 2 is 6, plus 2 more, that's 7. We had 5 coming in, and then we had 7 coming out. That doesn't make sense. There is a difference of 2, right? This must be 2 coming in. It has to be. And it's plus, so this is positive value. They didn't ask about that, whether it's coming in or out. They asked the value. If 5 was in, 7 was out, it has to be in equals out, so 5 in plus x is what we would have done. So that's 2 ways to figure it out, using the simple maths, which is self-explanatory, without using your brain, or you could just use your brain. Same idea here now, so let's just use our brain. We have 15 coming in, plus 5 coming in, plus 3 coming in. I don't care about this, but what's coming out? In. This must be equal to all of that, right? Because why? I in equals I out. So 15 plus 3 plus 5. 15 plus 3 plus 5 is 23. Over here, same thing is happening. Let me just get rid of that. We have the same thing happening. We have 3 coming in. Now it's just trying to figure out the formula. So I'm kind of glad I did it that way, so then you can see it. I in equals, I'll write I in equals I out. Same thing, I'll look at that. All the i's are on one side, just like I did earlier. So I in minus I out equals to, oh, that's a u by the way, 0. Okay, we've done that now. Of course, bringing it over to the side, we'll give it equal to 0. I in, what's in? I3 is in, I1 is in, I4 is in, but I2 is out. So I in, I will write I1, and I2 is minus because it's coming out, because I out is minus I2, plus I3, plus I4, and all that equals 0. So what is the best option here? B is the best option. I minus plus plus, there we go. According to this single loop circuit, so we are going to be single loop circuits, finding the current through the 4 ohm resistor, you could just use Ohm's law. The only thing you need to be careful about is the voltages. Are they in the same direction or are they in opposite direction? So this is why we're going to use the Kirchhoff's loop rule. K VL, Kirchhoff's voltage law. That basically says V gained is equal to V lost. So what you can do is what we normally have been doing is I'll just do V gained minus V lost equals to 0. And I can just shift solve. How many V's? What do I mean? So V is the same as IR. 1, 2, 3, 4. I have 4 components. So I will literally do V1, V2, V3, V4. I'll start a loop anyway. I kept pointing at this one, so I'll start from this one. I do like to start from the bigger number, to be honest. I will start from the positive side and work my way around like this. If there is no plus and minus, I must draw it. Plus and a minus. Plus and a minus. I have a plus and a minus, I cannot. Okay. A gained is when you go from negative to positive. Of course, you're going to the positive, you're gaining. If you're going from plus to minus, I'm losing. Plus towards the minus, to the negative side, you're losing. It's going down. So I will have V, I will call it V1, minus V2. I'm doing it slowly just so you fully understand the concept because any question can come. Minus V3. And now look, this is the key. Minus, plus to minus, minus V4 equals to 0. I will substitute IR wherever I cannot find it, okay? I will substitute IR and then solve for I. Essentially, that's the plan. So what I'm going to do is starting from here, 15 minus I, but I have 2, I times 2 because IR, right? I don't want to have to keep writing it. I times 2, so I'm going to write 2I. I hope that makes sense. 2I. It's the same current, by the way, because it's a series circuit. Minus V3, this is 4 times I, IR, right? 4 times I. It's the same current. Minus 9 equals to 0. And actually from here, you can just do shift solve. Minus 2 minus 4 is actually minus 6I. You can rearrange the formula to get I. Or if you're going to be lazy, which I think you probably will be, shift solve, you'll get the answer of current is 1 amp. All right, let's move on. Oh, by the way, if you do want me to go ahead and rearrange the formulas and do it properly, let me know in the comments. Which of the following represents the current I in the circuit below? So in this case, well, we cannot do shift solve. So yeah, it looks like I'm going to have to do it now. So over here, get a loop going. Let's do a little loop from here to here. There is a shortcut way, and then there is the normal way you're supposed to do it. We're going to do it the normal way, then maybe we'll check out the shortcut afterwards. V gained minus V lost equals to 0. I'm jumping straight to there. I have E1. So E1, this is got a plus, it's going from a negative to a positive, because I chose it. Plus minus, already written, plus minus, and let's begin. Minus, well, I have IR, right? IR. Minus, is that minus? That's minus this one. And then minus the other one, minus IR2, I'll call that one. IR2, and that equals to 0. So what we have is we're trying to solve for I, okay? So we're going to have to try and solve for I. So let's see if we can solve for I. First thing I'll do is I'll put the E's on one side and the IR's on the other side. So E minus E equals to, and this becomes a positive. If I take that there, that will also become a positive. So it becomes IR plus IR. IR2, IR1. First of all, E minus E, that means, well, that's wrong already, and that's wrong already. And now, take the I as a common factor, E minus E. Why is I the common factor, I hear you ask? Because it is a series circuit. The current is only flowing in one path, R plus R, and they are stuck together in a bracket now because I times R, as you know from algebra. Okay, so what does that mean? I want I only, so I will take my R plus R to the other side by dividing. I have to divide by R plus R, so E minus E over R plus R. This is how you get to the final answer, E minus E, R plus R. There we go, 1, 2, 1, and 2. The 1 and the 2 looks the same. That's accidental. Okay, great. Let's move on. Done that one. These are all cancelled. Which circuit shows in the figure is not going to function properly? I absolutely butchered that, so pretend I didn't do that. I don't have time to go back and edit the video. I've got like 50 more to make. All right, so where are we? What's this? We are trying to see which ones will work. Okay, so as you remember, voltages or voltmeters should be in parallel, ammeters should be in series. The voltmeter is measuring the potential difference across a resistor. We do not want electricity to flow through here, so it should be a high resistance, which is why a voltmeter is in parallel. It has high resistance. And this is also fine. Over here, an ammeter is measuring the current flowing through it, inside the wire. I want to see how much current is flowing. It will have a low resistance. It will be inside the circuit. Long story short, V parallel, the A inside. Okay, this is out, this is in. This is actually good. This is fine. This is not fine. This is fine. And what will happen here, because the A, like I said, has a low resistance, you've just short-circuited R2. So if a question asks you why is this a problem, well, A will short-circuit R2. Why would the current go through a resistor and have to use up energy when it can just easily pass through the ammeter and not use any energy? Current is lazy, a lot like a lot of you are clearly not in school today. All right. What's happening here? Wrong, wrong, and wrong. This is terrible. You know, I've got so many students that actually draw this in a circuit diagram, even after I explained it many times. So let's try this one. Oh, this is totally wrong as well. Look at that. This is fine. So, of course, the answer is just 1. All right, very good. Done, done, cancelled. All this is cancelled. I think there's a couple of questions here. Yes, there are. So over here, in an RC circuit, we have this. What is the time constant? Well, we know the formula from the formula sheet. Tau equals RC. Tau equals RC. So basically, all I'm going to do is I'm going to take 4 millifarads and multiply by 2,000. 2,000 times milli is times 10 to the minus 3. Please remember the milli, the micro, the mega. Make sure you know these. Centi, very important to know this. A lot of this will come, and especially in this type of question, because the numbers we use are small. Solving that question, getting that answer, will give you an answer, of course, and that will be 8 seconds. Very good. Okay, cancelled, cancelled, cancelled. Question 18, we're moving on now here. You have 1 mega ohm, you have this, you have that. Which is the best to determine the charge in coulombs? Okay, so what's happening here, by the way, is initially uncharged, meaning it will start charging. If my initial charge is 0, the only way it can go is up. It will charge. And luckily for you, discharging capacitors, for some reason, have been cancelled from this year's KPIs, so you only really need to know about the charging. Checking your formula sheet, the charging has the 1 minus. We went through this in the lesson video that I made, so I'm not going to go through this formula again and explain it, but it's long story short, 1 minus is for charging, E alone is discharging, so C is automatically out. So what we do is Q equals, because that Q, CV 1 minus E to the negative T over tau, T over RC. So we're going to have to check some things out here. So I will do C times V. The capacitance, which is 20 micro, multiplied by 5. 20 micro multiplied by 5 will clearly give me 100 times 10 to the minus 6. So I'll write that, 100 times 10 to the minus 6. 1 minus E to the negative T over RC. RC, what does that mean? R is 1 mega times 10 to the 6 multiplied by C, 20 times 10 to the minus 6. So the mega and the micro will actually cancel here. That becomes 20. So now over here, let's have a look. So this one is good, that's good, negative T over 20, that's nice. Why is B wrong? Because there is no minus here. There should be a minus here, so B is wrong. Why is D wrong? Well, there's no CV, there's no Q max, so that is wrong. So that means the answer is A. Okay, so I think we're approaching the end of these questions. I believe we have, yes, that's 3 response, the solution's already there. Let's have a look. A capacitor of capacitance, this is connected here, which the following represents Q max. Well, that's easy, Q equals CV, CV. In this case, they're talking about V, which is the EMF, E. CV, CV, that is the EMF, CV. Cancelled, and over here, you have this, which is representing the current. We did the simulation of this, and you'll realize that no matter what you do, the current is always coming down. The current is always decreasing. As soon as I close the switch, it will start to flow, but then it will get blocked by the capacitor. Slowly, 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 the current will decrease. So that's terrible. It goes all the way down. That's even worse. It goes all the way down. That's terrible as well. Forget it. Here. There we go. And that's everything done. Thank you.